Next, we're going to look at this problem. This problem has two linkages, AB and BC. We're told that this collar, this block, is moving to the right at 5 feet per second. So let's take a look at this. And so notice that block is confined to move in the x direction. It can't go anywhere except in the x direction. So we know that 5 feet per second. So if we look at the length AB, and let's say this is 8 feet, we know that this velocity A is going to be strictly in the I direction. So it's going to be 5I. Now, if you want to, you can, say it's going to be 0J, just to emphasize that's nothing in the Y direction, but it's enough if you want to just put 5J here. Now, also notice that point B is attached to this link right here, and this link is moving about a fixed center, C. And to recall that if you have a link like this that's moving about a fixed center, it's always going to be moving, the velocity in this end here is always going to be perpendicular to this point here, to whatever this bar is. This will always be perpendicular. So down here, we can say that this is going to be VB, and it'll be strictly in the Y direction because it happens to be at the point we're considering. This bar is just horizontal here, so that means this is going to be perpendicular. It's going to be strictly in the Y direction. So VB is going to be 0I plus some scalar called VBJ. So the only movement at this instant of this point B is going to be strictly in the Y direction. And keep in mind that when we're rotating, we're going to be rotating about the Z axis, because if we're in the XY plane, we'll be always rotating about the Z axis. So when we have like our rotation omega, it's going to be some scalar omega times K, which we're almost always going to use this form. And so for the equation, we're going to use the velocity of B is going to be equal to the velocity of A plus the velocity of B given A, or with respect to A. And now, in this context, for this term right here, we can rewrite that like this, plus omega cross RB with respect to A, like this. Now we're going to need to calculate, before we substitute into our equations, we're going to need to calculate some of these things. We're going to need RBA. So let me maybe make a little box here. And it's going to be 8. Again, remember, if we're doing RBA, we're going to start at A and go to B. So if you want to go in the X direction to get from A to B in the X direction, you're going to have to go this way. And now that's going to be, the X component is going to be 8 cosine 20. I. So in other words, we have to go from here to this point in the x direction, and we have to go down. Now, since we're going down, that'll be negative. And again, if this was cosine, this has to be sine. 8 sine. So it'll be 8 sine 20 degrees. And so again, to get from A to B in the x direction, 8 cos 20. In the y direction, 8 sine 20. And then when you put these in your calculator, to I that's 2.74 J like this. And so now we're going to need omega cross RBA. And so it's going to be omega cross BA. Make this straight line here. And that's going to be IJK. And then remember up here, the vector omega was omega k. So it's going to be 0, 0, omega. And again, cross RBA, we have RBA right here. Like this. And now we'll calculate this. That's going to be times I, that'll be negative of a negative 2.74 I. 2.74 omega I. And then for J, again, it'll be negative, but again, the J position's negative, so I'll be positive. 7.52 omega J, like this. Now we can substitute all this stuff into our equation. So we're going to go back and substitute into this. Let me just write that equation down again, just so it's clear. So B equals BA omega RBA. This, and we're substitute in. We know VA, we wrote that down before. That was 5I. Now I'm going to leave off the 0J. And then for this quantity, that's this up here, 2.74 omega I, 7.52 omega J, like this. Now, also on the left-hand side, we know that VB was of this form here. And so we can actually replace the left-hand side with this. So on the left-hand side, we can actually put, we know there's no I component. So we can say VBJ like this. And so let's set, so match the components, set the components equal, or set coefficients. So let's say, for example, let's look at the i's. So if we set the i's equal, we just have these components here. These are the only components with i's in them. So we'll have 0 equal to 5 plus 2.74 omega. And if we solve for omega, we get minus 1.833 radians per second. And remember, because it's negative, that indicates that it's clockwise. And then finally, now we can find VB, because again, if we set the J's equal, over here, the J's, we have VB is equal to 7.52 omega. And then VB is going to be equal 7.52. We just found the omega, 1.83. This was negative 13.74 feet per second, like that. Then finally, we want to find the angular velocity of length BC. So let's take a look at that. So look at BC here. And we said, now for this, we can do just a very simple calculation, because we know this is perpendicular. So we can just use the fact that the velocity is going to be equal to the radius times the omega of this length. So again, this omega up here was for AB. Let me just mark that. That was for the length AB. Now we want to look at BC. So for length BC, we have something like this. When we said, we just found that the velocity of B was equal to, and let me just work with a scalar right now. We're just going to work with a scalar quantity. VB was equal, we just calculated 13.74 feet per second. But then also, we know that that's going to be equal to the radius here, which was given as 3 feet. Times omega of BC. Again, we know that this is negative 13.74. RBC was 3 feet. And then omega BC, when we solve for that, is going to be negative 4.58 radians per second, like that. And so we found everything that we wanted to find. We found the angular velocity of AB, and that was negative, so that was clockwise. And we found the angular velocity of BC. Once again, that was negative, so that must also mean clockwise. And we found the velocity of point B. Like that. Next, we're going to take a look at this problem. Once again, we have a couple of lengths, AB and BC. AB is rotating at 3 radians per second. And we need to find the angular velocity length BC at the instant theta is 45 degrees. So let's take a look at this. Again, you always want to start with whatever you know. We know something about AB. We know that it's rotating at 3 radians per second. And also, as we've said many times, if you have a link rotating about a fixed center, then the velocity will always be perpendicular to that link. So in this case here, the velocity, actually I called it A, but it's actually the velocity at B is going to be in this direction. And of course, it's always going to be the radius of the arm times omega. In this case, it's going to be the arm length is 0.5 and omega is 3. This is 1.5 meters per second. And so that gives us this. And then also, because this is 45, one thing nice, when something is 45 degrees, usually all the angles will be 45 degrees. You don't really even have to give it much thought. And so now if we want the vector form of VB, so this is going to be VB, and it's going to be the 1.5. And now for the X direction, which is going to be our I direction, you can see that it's going to be cosine of 45 degrees. And also because notice the X will be in the negative direction, this will end up being a negative 1.5 cos 45 I. Then for the Y direction, if this was cosine, that'll be sine. 1.5 sine 45 J. And when you put this into your calculator, we get something like minus 1.067 I. And over here, 1.067 J. And so that gives us some information about this. And so now that we have this VB vector, now we can start looking at this link over here. So next, let's look at the link BC. And what do we know about it? First of all, we know that this is horizontal. And we also know, again, if this is C, this is B, and of course, the velocity, we found the velocity of B over here. And now notice that C is confined. It can only move in the X direction. So we can at least say a little bit about, we know that VC, velocity of C, is going to be some scalar times I, and there's going to be nothing in the Y direction, 0J, because it cannot move in the Y direction. So that'll be the form of the velocity of point C. And we know this velocity here. And we're going to also need, let's write down maybe the equation that we're going to need. We're going to need the equation VC equal VB plus omega cross RCB, like this. Now we know VC and also the RCB, we're going to need that. So RCB, that means if you're starting at B and you want to go to C, and we know that this link is 1.5 meters long from up here. So to go from B to C, let me write it up here, CB. But if we have CB, that means we're going to start at B and go to C. It looks like we have to go in the negative direction, 1.5 in the X and nothing in the Y, like this. So then, what else are we going to need? So I think that's pretty much it. Now we can do this calculation. We can calculate omega cross RCB. And remember, omega is going to be 0 omega times RCB, and that's going to be like negative 1.500, like this. And then when we calculate that, we're going to get 0I. And then when we do this one, it'll be a negative of a negative of a negative. So that looks like that's going to be negative 1.5 omega J, like this. And when we do the K term, that's also going to be 0. Now, I probably should put here this omega is going to be, the link we're working with is BC, so we can call that omega BC, BC like this. Now, if we put everything into our equation up here, at VC, VB, plus omega cross RCB. And we've said that VC was in this form, VCI. And we also previously found that VB was this. And we just calculated this omega RCB up here. And we don't need to put these zeros in. We can just call this minus 1.5 omega BCJ like this. And so we can set our terms equal. Let's set our coefficient. Let's focus first on the i's. So set the coefficients of i's equal. That gives us VC is negative 1.67. And what are we working with? We're working with meters. So that'd be meters per second. And then for the j's, set the j's equal all the j coefficients. This is going to be 0 equal 1.067, 1.5 omega BC. And we'll work that out. 0.717 radians per second. So we found the velocity of block C. And because it's negative, that must mean that it's going to the left. And then omega BC was the other thing that we had defined, and that was 0.7071. And because it's positive, this must be counterclockwise. Next, let's take a look at this problem. Find the angular velocity of link AB. Excuse me, the angular velocity of link AB is 4 radians per second. Find the velocity of the color C and the angular velocity of link BC at the instant shown. Link BCB is horizontal at that instant. So let's take a look at this. So as usual, we'll start with what we know. We know some information about AB, so we'll work with that. And as usual, notice AB is moving around this fixed center. So if the center's fixed, as we said many times before, that means that the velocity will be in a direction perpendicular to the link, something like this. So let me make another picture here. So let's say if we have this link here. Again, as I mentioned, this is B and this is A. Again, this is fixed. And this is 60 degrees. And of course, then that would make this over here 30 degrees. If we make a little triangle, this is 60 degrees and 30 degrees here. And then this length this is 500 millimeters or 0.5 meters. And again, this is turning AB is counterclockwise at 4 radians per second. And so what else do we know? Now, of course, we know that we know this radius, we know this angular velocity, so we can calculate the scalar value of B is going to be, again, R omega AB. And so it's going to be 0.5 meters times 4 radians per second. So that's going to be 2 meters per second. That's going to be the velocity of B. And then we want to put that into terms of a vector. And so we can, let me write this down here. Velocity of B. So it's going to be this 2. Now, if we look at this picture here, the x component is going to be cosine of 30 I. And notice the x component is going in the negative direction. And then the y component is going to be 2 sine 30 j, like this. And so if you put those into your calculator, we get VB is equal to negative 1.732 I plus 1J. So we just put J like this. So now we have some more information. Now we can move on to look at link CB. Link CB is this one right here. And so link CB. And it's going to look something like this. CB, and then this one is going up like this, like is it just shown here. Now this other one here, notice that this is 35 degrees with horizontal, and this is horizontal as well, so that's going to make this 35 degrees. So that means C is going to be moving in this direction here. So we have velocity of B was in this direction. Velocity of C is in this direction. And now we don't know what the velocity of C is, but since we know the direction, we could give some description of it. So we can say this VC, again, this is 35 degrees. So whatever this number is, it's going to be some scalar value of the velocity times, again, the x direction will be cosine. That's going to be positive in the x direction. And then VC sine 35. And that's going to be going in the j direction. And so if you put these into your calculator, you will get 707 VCI plus 707 VCJ, like this. And again, we want to find the velocity of C. So keep in mind what we're going to use. We're going to use our normal equation. which will be VC equals VB plus omega BC cross CB like this. So realize we're going to need RCB. And remember, if we have RCB, that means you're going to start at B and go to C. And let's find that distance is 0.35. I could probably have put it up here. 0.35 meters. So RCB 0.35 I. Now this says we're starting at B and going to C, so it looks like that'll be a negative, like this. And so let's calculate this term right here. And remember, omega BC is going to be a form something like this. And then this was negative 0.3500. And we calculate this, that's going to be what, 0I. And then we do the next one. For J, it'll be J is negative, and then this is negative, but it's also subtractively negative. So 3 negatives make a negative. 0.35 omega BCJ, and then K will be 0. So we can probably just write this 0.35 omega BC. So we calculated all that. And let's substitute into our equation. So we know VC from here, at least the form of it. And we know VB from up here. Then omega BC cross CB. This. And let's set the terms equal to each other. The coefficients, let's start with the i's. Oh, I left off a J right here. Please fix that. I left the J off right there. Be sure to put that in. That was from this term here. And so the I is this. So we're going to have 0.707 VC minus 1.732. And that's going to give us VC is negative 2.45 meters per second. And then set the J's equal. So let's set those up. And so we're going to have 707 VC equals 1 minus 0.35 omega BC. Now we know VC from up here, so we can put that in 707 VC, which I didn't put in. Negative 2.45 707 minus 1 divided by minus 0.35. I'm given omega BC is 7.81 radians per second. And since it's positive, it must be counterclockwise. And that's what we found everything we're supposed to find. We're supposed to find the velocity of color C and omega BC.